Hey, Jody here with weldingtipsandtricks.com. We're TIG welding aluminum today. A horizontal butt joint. It's going to be right here in front of me. Nothing super difficult. Just a little bit more difficult than if I were laying it in the flat position on the bench in front of me, but not too hard. But it lets us talk about the importance of cleanliness of the metal, because I want good, complete, smooth penetration on the backside, and that's a little bit hard to do if you don't clean the metal right. So we'll talk about that today, show plenty of shots front and back, correlate the arc with what's going on the penetration side. And at the end of the video, the last, I want to say 2 minutes or so, will be a commercial. I'm telling you that now. Buckle up, get ready for it. It's a commercial on my TIG finger product. All right, let's get into it. All right, for starters, just so I can get my camera settings all dialed in and cameras positioned, let's just run a little quick bead horizontal here on a plain blank piece of metal. I'll run about 1 inch here. I'm going to be doing a whole lot of this for this video, having 2 cameras set up where you can see front and back and little shots like this. I think that's educational to do that. Here are the settings used for everything in this video. You can pause it if you're interested in seeing all these details. Set up in the horizontal position. I want to point my torch upward at about 5 to 10 degrees. And this piece was just basically wiped down very thoroughly with acetone. This is some flat bar here, about not quite 1/8 of an inch thick. You can see some fine porosity right there when I first lit up. So it could have been a little cleaner. So it takes a minute to melt through, and you see that's what we call the baby's butt effect there right at the beginning. And you can actually get that for a really long way, thinking you're penetrating. And you kind of are penetrating, but the 2 pieces just aren't joining together on the back side because there's an oxide line there that's very resistant to joining together. So you got to use enough heat to do that. You can see it's at the very beginning of the puddle there. It's got that line too, but it's hot enough to punch through and where everything does join together. It's still not a desirable effect. That distinct oxide line is because I didn't clean these edges well enough. We'll do one where I clean it really thoroughly later. For restarts, a pre-flow really helps on aluminum. It helps avoid that sooty restart. And a restart of about 1 to 1.5 seconds sometimes is needed. This machine has a built-in pre-flow of around 1/2 a second. And sometimes I just bump the pedal and get longer for aluminum. So I'm trying to weld it hot enough that it sinks through and I can kind of watch that puddle sink a little bit. It can be very deceptive though. All right, let's watch the back side of this one. Again, this piece is not extremely thoroughly cleaned on those edges. And if you want full, smooth, clean penetration on the back side, if that's what the job calls for, you'll do yourself a big favor to take a lot of care in cleaning the edges. Now watch here, things are going pretty decent, but there's some trash going on there, some little black stuff pushing through. It could have even been the markings, the ink markings on this piece near the edge or something that I just didn't clean off very much. So I thought I had it kind of clean, but to get that smooth penetration on the back side, I need to be a little bit hotter and I need it cleaner. That's kind of rough right there. And where I tie in here, it didn't quite tie in like I would like to see it. See, I didn't quite consume that little baby's butt area. So, you know, if this was a joint that was going to be tested, like by X-ray or something, wouldn't pass. I'm in the habit of adding a little extra rod when I stop to avoid a crater crack. All right, just for demonstration purposes now, I'm going to run a real quick bead on a scribed line right above that bead after it cooled off. And I won't you know, watch the whole thing here. I just want to run it and then look at the back side, and it just further demonstrates that effect from the oxide line on the edge. On that seam joint where there was actually a joint there, you can see a distinct oxide line there, and then I didn't penetrate very well in the middle. And on the top where there was no joint, it was just metal, it's nice and smooth, or a lot smoother anyway. Now this piece I really cleaned thoroughly. I wire wheeled it with a stainless wire wheel brush. I filed the edges really thoroughly. I set the machine on 140 amps, and at full penetration, where I thought I was getting full penetration and the camera told me I was, 131 amps was about right. So this is going pretty clean. Could be just a little bit cleaner, and when I get finished here with this bead, we're going to look at a little bit of something they call pepper in the puddle. It's just some fine black specks. And usually that can be caused by a lot of things. It can be contamination and everything, but in this case, I think it was I didn't quite have enough argon flow. You know, when you're welding horizontal like this, argon's heavier than air, tends to kind of want to fall downward. So if you don't have enough flow, sometimes the top of your bead won't have much cleaning action, and you get this little effect here. So I got some pepper in the puddle. So I turned the argon rate up on my number 8 cup to 25 instead of 20 CFH, and that seemed to go away. And from doing this joint, from cleaning this joint very thoroughly, like I said, nice wire wheel with a clean wire wheel, stainless steel wire wheel, filed the edge really clean, wiped it with acetone, and I've got enough argon to where the front side's going clean. This penetration now is going a lot better. You can still see a fine oxide line. Sometimes it's just hard to get rid of that because that oxide forms immediately after you file it off. It's just not very thick as it is if it's just left to sit for a long time. Again, as I overlap a little bit to make sure I get full penetration, taper off, add an extra dab or two of filler, do a little swirl with the arc to avoid a crater crack. That's best practice, what works for me on aluminum. So that little last half there did the best. Pretty clean, full penetration, smooth penetration, and the backside came out pretty good. So the answer to the question of what's clean enough is it depends on the application. If you want smooth penetration on the backside, you got to go to a little bit more effort in cleaning your aluminum. All right, this is a little throwback here to a previous video, just to show you that this is done in a fixture. I wasn't using argon backing gas. The fixture is capable of it. But this is much thinner. This is 063 material, and very easy to penetrate that stuff. And I'll show you the back side of that in just a minute. Now, I was very thorough for this joint. I mean, I filed the edge clean, and then I filed some more, wiped it really well with acetone, and then welded it immediately after cleaning. And again, just being thinner, much easier to penetrate. Being in a fixture, something that kind of confines the heat, also helps. Obviously, you can't have that luxury all the time, but penetration on the backside really shows the effort that I went to on cleaning. All right, now this is the commercial part here. I'm going to run this 12-inch long aluminum sample here with my TIG finger on. Now, it's thicker on one side than it is on the other because there's more layers, and that's the side that I use for the heat side, you know, to resting against something that's really super hot. Now, the benefit is it's going to protect my finger from heat, but it's also going to slide along this piece nice and smoothly. And, you know, if on a long run like this, if I want to make a 12-inch run without stopping, my filler rod will make it that far. At the very end, I'll do a little pivot there. And because I don't have any, you know, this piece is only so long, and I've got vice grips clamped off to the end. I'm going to show you how hot this thing gets with this little infrared thermometer here. And so I won't show the whole thing because it takes a minute or two to weld this thing out, but I just want to show, you know, you can kind of sense right here pretty early on, if you didn't have the TIG finger on and you didn't have any other place to prop and you were resting your glove on this piece, it will get to cooking your fingers pretty good. You know, if this was a patch on a pontoon boat, a tank of some kind, a reservoir, aluminum transmission housing or whatever, they all get really hot. So you can show this piece is getting up near 500 degrees near the where my finger is anyway, but I didn't feel any heat. And of course, you have to take my word for that, right? But it works great. It works great for things like this, and even for anything where you don't have a place to prop like this. I would have had to gone to great effort to clamp something up to the table to prop against this chunk of stainless here. But basically, I've got my prop in my pocket because you know, when I'm working in the shop, I just keep a TIG finger on the bench or in my pocket, and I don't have to have a place to prop. I prop right next to the weld, and I can keep my finger there for 5 minutes if I want to, and it won't get hot. So I've got a TIG finger and a TIG finger XL. The XL is just thicker and more heat resistant. It's bigger. You can fit 2 fingers in it usually. It's for those heavy preheated items. 100% sourced and assembled in the USA, made by friends and family. Hey, I appreciate you watching very much. My store is at weldmonger.com. See you next time.